All right, off we go to a discussion about the future of service assurance in telecoms. And for that, I'm happy to welcome back Ross Cassan, who is Senior Director of Assurance Strategy at Spirent. How are you, Ross?
I'm doing great. Thanks a million, Kelly.
Good, great. Well, you folks had a chance to hear from Ross a little bit this morning already. So we are going to let him talk a lot more about service assurance. And again, if you have questions, please submit those and we will get to them at the end if we have time. So Ross, please go ahead.
Thanks a lot. And yeah, let's get into some use cases. Now, before we get into the use cases, let's talk a little bit about, what we're seeing, what are the major challenges across our customer base, who are the telcos, also the cloud scalers now, are using our assurance solutions. So what we see is definitely with 5G and SA, just a rapid change in how the networks are architected, right? From moving from physical infrastructure to cloud infrastructure, expansion on the edge, definitely the growing use of virtualization. Carriers are going from consumers of network infrastructure to providers of the very fabric that these network services run on. And so that comes with, a lot of demand for testing uh, and being able to support not only the infrastructure, but then the proliferation of network functions and protocols that ride on top of that. And then we also see the need, of course, to continue supporting legacy technologies as we move into new technologies and new services. In terms of operational constraints, it's the unfortunate reality for most of us that we're being asked to do more, integrate these new services, and sometimes at the same time be responsible for reducing operational expenses. Um, and the reality that we're seeing in many of our customers is we're still dealing with kind of silos that are created around different segments of the network and different network functions. And an increasing volume of new services that are driving more alarms in the network, uh, and then also a shortage of skilled personnel. And then on top of that, we're trying to decrease OpEx on one side, and we're trying to increase revenues on the other to grow our revenues for the shareholders. And so now that carriers have deployed 5G technology and are moving to SA in the network, standalone 5G technology, we see new services being added, a big focus on enterprise services. So things like enterprise fixed wireless networks, private 5G networks for enterprise, and even enterprise slicing, as well as new consumer services. And these are bringing with them new regulatory requirements, additional SLA requirements, which is kind of a new thing for the mobile network. And lastly, the goal is to just be able to bring all of these things to market quickly. So I wanted to talk briefly about what we refer to as active service assurance and introduce the concept, and then talk about, how it is evolving in the world of AI ops. So active service assurance is just that. It's active. We're actively injecting traffic into the network to measure the spot response, right? It's basic stimulus response. Sometimes this is done in a one-arm test where we're actually testing to a real service. We're emulating a real subscriber uh, uh, consuming a service in the network. So, for example, a simple test would be going to Google, going to Facebook, or whatever service you're trying to use. And we also have two-arm tests where we actually send traffic between two agents to measure a particular function in the network. So how active assurance is being used in the age of AI ops, starts at the beginning of time for a new service. So just accelerating that deployment and automating the testing that goes along with the deployment of a new service. So having that confidence that as you deploy a new service, you have a birth certificate, it's meeting its design objectives, and automating that entire process so that we can get, a much faster time to market and deploy that service. Once the service is up and running, we move into performance monitoring, where we're proactively trying to identify, is the network degraded, and detecting that before a customer might even call in. And so we're starting to use AI technology to detect those degradations as they start to occur, and are successfully doing fault identification before we even see things online, and crowdsourced sources detecting the issue. One of the things that we hear a lot from our customers is this concept of alert fatigue, and just getting too much noise out of the system and needing to filter that. And this is a great application for AI technology, is to use LLM technology and also use filtering capability to really understand what are the important things to focus on in the network. And we'll get into that with the use cases as we go through them. And lastly is operational efficiency, right? We need to um, make the job easy for humans. So we want to do things like automating the triage procedure and making sure that we're providing as much information as we can to the folks that are solving the problem, and also getting the right folks in the room. There's so many times when I hear about outage bridges that have every possible network function, at the beginning of an outage, and trying to determine, what segment of the network has caused the problem, and identifying that takes a lot of resource. All right, so let's get into the case studies. And so the first case study is around a kind of a next generation mobile slice that's used for enterprise service assurance. And at the beginning, before we started working with this customer, uh, their customers were demanding SLAs from them. Um, and they had to do a lot of testing manually whenever a change was made. And so they weren't able to test every one of their customers that were consuming these services. And these customers were, Fortune 500 companies, large customers. Uh, and so they just didn't have the ability to test every one of the different services they had. They had multiple different tools, and that complicated the reporting. And they really didn't have good end-to-end visibility, and were often getting calls from their customers when things weren't going well. And that was the first time they would hear about an issue, is when their customer called in. And so with active test technology and automated fault isolation, we've been able to evolve that to the point where within a 5-minute window, all 5,000 of those slices are being tested every 5 minutes. Um, and so they have great visibility of the the network. They're leveraging, the SLAs that come with fixed line, and implementing that now for 5G, so they can offer SLAs to their customers. Um, this is great for rolling out new patches and fixes into the network, because they instantly get feedback. Yes, this is working well. No, I need to stop and roll back and take it back to the lab and figure out why there's a problem. And we've also seen the ability to detect issues up to 8 hours before an SLA violation occurs. And so that's that trend analysis capability, and using AI and ML to detect differences day to day, week to week in the traffic patterns, and then do triaging and alert the customer to that. Um, so I'm showing a dashboard of what that view looks like. We've got, different groups of services, and showing different qualities for those, as well as all of their enterprise customers and the top 10 violators on this particular screen. And screens are great. It's a great way for an operations team to see the health of the network. But we also want to be proactive. So in addition to the screen, there's a lot of notifications that are happening in the background, um, that stay within the system, And when those occur, they kick off workflows that go and do a deeper analysis to understand where the issue is happening within the network. And the way that that works is by using these active test agents. And so you can think of these as virtual or containerized agents that are sitting in the network and have the ability to run end-to-end tests. But then when there's an issue in that end-to-end test, also have the ability to basically kind of appear, and this is done by a combination of virtualization techniques and just IP routing to get to the different interfaces in the network so that automated workflows can be done to identify what is causing a particular fault. So if we see something like an increase in network latency, we can identify that, hey, this is because of a change that was done on the backhaul network, or it was something that was happening in the mobile core or in the RAN, and being able to identify what the source of that particular issue is. All right, so let's go to the next use case. So this is another carrier that we work with. This is actually a fixed line service, and the carrier, was seeing, a 25% reduction demand in their OpEx. Uh, at the time when we first engaged with them, their detection was really triggered by customer complaints, so customers calling in or issues being detected um, through crowdsourced applications. Um, a lot of the testing that they were doing at the time, and I think this is a fixed line enterprise service, and many customers still do this to date. Um, they require testing from both ends, and so they were having to roll trucks, roll equipment, and engineers out to be able to measure, the traffic from both sides and identify, where the issue was. And we took a very different view towards doing this. We took a very big focus on automation with this customer. So we wanted to be able to automate as much of this as possible in terms of the workflow of identifying where issues are in the network. Um, and also really focusing on eliminating the need to send resources out into the field. And if we do have to send resources out into the field, we want to be very pointed in what those resources need to do and who they are, because there are all kinds of different skill sets when it comes to field technicians. And so the model that we use focuses on turning the devices that are deployed at the far edge into reflectors and uh, test agents effectively. So we can turn the router at the customer premise or the network interface device into a piece of test equipment so that we don't have to send somebody out there and then run all the tests automated from a central location. And this has really allowed us to decrease the amount of time to detect issues and also, really focus on uh, automation within the network such that, tickets come into the network and we can automatically trigger the triage. We can automatically find the fault in this network, and sometimes not even involving a human. And sometimes when we need to, we can package up all of the test results and provide them over to a human who can then action them. And so this is what the process looks like, right? So when we're continuously running tests, there's a signature that gets tripped. And at this point, we've got the robot indicating this is all done in automation. And then we move into a fault identification and fault analysis mode. And then we can send a notification back to the originating customer if they called in or created a ticket for a complaint, like on a network outage. If there was no fault found, we can provide that information directly back to the originating customer in a ticket. Or we can package that up and say, yes, there was a fault found. It's at this portion of the network, and we need to roll a truck to go fix a fiber cut or identifying where the issue is. All right, and the last use case I wanted to go over was focused on a customer that's going through a cloud consolidation and migration. So many of our customers are doing this, especially around 5G core infrastructure and even 5G RAN now, where it's being migrated from physical infrastructure into there was kind of a phase where all of the infrastructure was coming from the network equipment vendors, now to a model where the carrier themselves are owning that cloud infrastructure. And so at the beginning of time, we saw a lack of test capability, still these separate tools, and then no correlation between the actual cloud infrastructure and then the applications that were running on top of that, the network functions. And so by bringing active tests into this, we're able to not only see what's happening at a particular network function level and making sure that, if it's a mobile subscriber, that they're able to get onto the network. So we're emulating mobile subscribers, they can get onto the network, and we can see what's going on. But in addition to that, correlating what's happening at the cloud infrastructure level, and being able to wrap all of that together for the carrier customer. And so this starts at the beginning of time. So this is a CI/CD pipeline that's been created, and it starts in the lab phase and then moves into service assurance. And while we're showing this kind of linearly for simplicity, this is actually a cycle that occurs where something starts in the lab as a new service, it moves into staging, and then we take that test capability and optimize it for service assurance in the live operation. All right, and I just wanted to close with the platform that we've been talking about that enables this. So this is Spirent's VisionWorks platform that has enabled all of these use cases. It's a platform for active service assurance and also allows us to ingest other information such as passive or information from the network functions themselves and the telemetry that's coming from that system. It has a massive focus on automation for certification and activation of new circuits. It focuses on performance monitoring to ensure SLAs and that we're delivering a good quality of service to our customers. And if a problem is detected, can automatically move into root cause analysis and then providing that information out to either an automated system in a closed loop example or out to engineers. And ultimately, our goal is to future-proof network operations and really simplify the entire end-to-end cycle of delivering new services.
Okay, so Ross, I'm going to follow up on that. Since you're already talking about the tools, we actually did have a question from the audience about asking for a little bit more elaboration on what and how the tools were used on that end-to-end network slice performance case study that you talked about. And I think there's an interesting aspect to this question because they ask about how slices would be distributed across multiple regions in an operator network. So that brings sort of the geographic question into this as well. Can you give us a little bit more in terms of insight?
Yeah, absolutely. So when we look at something like network slicing, obviously it goes all the way out across the RAN. So when we're looking at the tool set to monitor that, it starts at the edge with RF tools. So we have a combination of physical RF tools that can get placed into the network. Our customers typically place them, close to their customers, and we can also turn end customer equipment into test reflector capability, as we talked about. And then when we move into the network, we're then using virtualized agents that get positioned throughout the network that allow us to do fault isolation so that if we do detect something in those end-to-end tests, we can identify, where is it occurring? Because slicing really involves the entire network, right? It uses different service levels and different spectrum even over the RAN network. It can use different backhaul circuit, and then it can go through even a different UPF in the core of the network. So There's a lot going on there, and all of those things have to be coordinated.
Okay. Wonderful. Well, thank you so much. The examples were wonderful. I'm so glad that we got a chance to get into that additional detail. Thank you so much for the time and the expertise. Always good to hear from you.
Awesome. Well, thank you all, and thank you, Kelly.
Yeah. Great. Thanks. Next up is an NTN panel, so stay tuned.